Welcome back to the Curious Clinicians, a medical podcast that asks why. I'm Hannah Abrams, and I'm joined by Avi Cooper and Tony Brew. Hey, guys.
Hannah, Avi, how you guys doing?
Good evening.
Hello, hello. All right, well, we have an extra special guest today. We are delighted to be joined by our first repeat guest on the podcast, Dr. Mike Todorovic. Welcome back to the show, Mike.
Thank you. Thank you. How are you all?
Excited to talk to someone who's in a totally different time zone. I'm used to Hannah being 3 hours, but you're significantly more than that.
Yes, welcome to the future. It's beautiful here.
You know, Mike, we had you on almost a year ago, at least at the time of recording, but I didn't get a chance to sit in on that episode. I can't remember
I
if I
know.
was under the weather or if my son or daughter was under the weather, but I know your backstory, but it might be helpful for you to remind me a little bit, remind the audience a little bit, like who are you? What do you do? Tell us everything about Mike.
Sure. Can I first say I was insulted when you didn't turn up to that podcast?
Rightfully so.
But it is wonderful to finally meet you. And I have to say in the very front, I said it the last time I was on the pod that I love the Curious Clinicians pod. I listen to it every single week, every episode that comes out. I love it. I recommend it to everybody. It's that perfect mixture of the physiology, which I love, and I'm not a clinician, so I don't have clinical experience, but what I get from the Curious Clinicians pod is that clinical relevance. So thank you for having me on again. A little bit about me. I'm an associate professor within the Bond University Medical Program in Queensland, Australia. Like I said, in the future, it's winter here, but it's nice and sunny, which is nice. But I'm also the co-director of Dr. Matt and Dr. Mike's Medical Education, which is an online medical education company, which predominantly it teaches anatomy, physiology, pathophysiology, pharmacology on YouTube. And yesterday we hit our 1 millionth subscriber on YouTube, which is wonderful. So we should be getting our gold button soon, which my kids are super excited about. My kids just think it's amazing that I've got a silver button and a gold button that YouTube gives us. And we do a podcast as well, Dr. Matt and Dr. Mike's Medical Podcast, which is consistently in the top 10 medical podcasts in Apple and Spotify. And we provide online medical resources. So if anybody wants to, follow us or contact us, you can go to our website, which is drmattdrmike.com.au. And part of what I do is just talk to people about how the human body works, try and make complex stuff easy if possible.
Amazing. 1 million subscribers. That is a lot of people.
It's especially considering it's me standing in front of a whiteboard, just drawing and talking. I think that is just amazing. It shows that there's an appetite for education, and you don't have to be controversial, and you don't have to, be polarizing to build a nice community. So it's wonderful. It's really nice.
It's very hopeful. That this kind of content can get that kind of traction. So that is amazing.
Thank you.
To just sort of be a beacon of positivity and education and curiosity on the internet. We need a lot more of that. But as we discussed on episode 96, we did it when Dr. Mike was here the first time. We did a deep dive on the sodium potassium ATPase pump. You're an extraordinarily talented educator. Your ability to break down complex concepts in really easy to understand and digestible way is really unmatched, I think. And obviously, clearly millions of people are watching your content, but if you haven't checked out Mike's videos on YouTube or listened to his podcast with Dr. Matt, that's Dr. Matt and Dr. Mike's Medical Podcast, as he said, with Matt Barton. These are amazing resources that will really teach you almost anything you want to know about how the human body works. But that's not why we have Mike back on the podcast tonight. He's back because he and Matt have written a book. It's called The Body. Is it A to Z, A to Z? I want to make sure we pronounce it correctly for you.
Well, where I'm A to Z, the human body. Yes. But you can say A to Z, that's fine. My kids watch enough YouTube from the States that they say A to Z as well. So whichever way.
All right, maybe we'll mix it up. It's going to be published by Simon & Schuster in the fall of 2025. We're actually going to be releasing this episode on the day that the book is launching, October 29th, 2025. And it's available for ordering now when you're hearing this. And Mike, we're so excited for your book to come out. Congratulations to you and Matt on this amazing achievement. Can you tell us a little bit about the book?
Yes, thank you. It is exciting. I think Matt and I have always spoken about writing a book. We know that, we've got YouTube and podcasts, and we did radio for years. ABC, which is the Australian Broadcasting Corporation, so our national sort of radio station. We did that for many years, and we also thought, well, what other medium can we sort of jump into that we haven't yet? And we've always wanted to do a book, and then the question was, what do we write a book about? And so at the time, we were doing some short podcast episodes on taking a physiology textbook, opening it up to the back and looking at the index and going through every single, we regretted it at the time, but going through every single letter of the alphabet and every single term in that reference list and making a 5-minute episode on it. And we had a lot of fun doing it. And we thought, why don't we just take the human body A to Z? We'll take some well-known structures and functions and some lesser-known structures and functions and sort of just talk about it one page. So the great thing about the book is that it's one of those books you can take to bed and you read one chapter and you can go to sleep. It'll be 1.5 to 2 pages per chapter. It's just one letter of each body part, structure, function. And it's, just made easy. And I promise you'll learn something at the end of every chapter and hopefully find it at least entertaining in some regard.
I love that in the modern era, the final medium frontier is paper.
So true. It's so true. It's so true. But
We're the same.
it's interesting though, because you can reach, we reach 1.7 million people a month on our videos, and that's just the YouTube videos. And it's sort of dismissed. It's like, oh yeah, that's great. That's really wonderful. And it's like, but let's write a book, and so much time and energy. And we're not even going to get anywhere close to 1.7 million people reading this book. Right. But for some reason, it's something special within those covers. And I don't think we'll ever get over that, to be honest.
Well,
Yeah.
you'll have the book on the shelf behind you while you're recording
That's
your
true.
YouTube videos. So there's that.
Yes, that's true. We can go with all the other books I haven't read.
That must be under G for gravitas. But we are going to give our listeners a taste of the book today, even if it's not that, the paper. We're going to unpack 3 of the questions, the topics that Dr. Matt and Dr. Mike, you guys are explaining in the body A to Z. So I get to kick us off, I'm excited, with a particularly fascinating one, I think, which is the question of why people who have Parkinson's disease can ride a bicycle but have trouble doing things that seem simpler, like buttoning a shirt. Take it away.
It's really interesting, right? So I did my PhD in Parkinson's disease. I looked at some of the genetics of Parkinson's, and meeting many people with Parkinson's disease, you'll see that there's some what seem to be relatively simple motor tasks that we take for granted that they can't do. And then one day I saw a YouTube video of somebody with Parkinson's disease finding it difficult to walk up to a bike, but hop on a bike and ride it no problem. And then that always got me thinking for years and years and years, why is this the case? And I thought, well, this is a perfect topic to write a book chapter on. Now, when we think of Parkinson's disease, right, we think of those cardinal signs. So the resting tremor, that postural instability, the shuffling gait, and all of that is sort of seeded in the death of dopamine producing neurons in the brain, in a very deep part of the brain called the substantia nigra, which just means dark substance because of the dopamine that it's producing. And so effectively, when you want to perform some sort of motor task, your motor cortex will send a signal that asks what's called the basal nuclei, which many years ago we called the basal ganglia, ask it for permission, right? So let's just say I want to use a muscle group within my legs. I want to use it for walking, let's say. It asks the basal nuclei for permission. Now, the thing is, the basal nuclei, very complex neurocircuitry, but it has 2 major pathways. It's got a pathway in which the motor cortex says, can I move? And one pathway from the basal nuclei says, yes, you can. And then another simultaneous pathway says, no, you can't. And so that seems strange that you've got this yes, no coming from the basal nuclei. But this is where dopamine comes in. So the dopamine that's produced from the substantia nigra sort of projects up and gets released. And it will reinforce, or say, it basically reinforces the yes signal and inhibits the no signal. So what you get is the ability to smooth out motor movement. You can initiate that motor movement and it smooths that movement out. And the question of why is there this simultaneous yes, no, it's complex, but has to do with, you've got agonistic and antagonistic muscles. So muscles will some need to fire while others need to be inhibited. So the basal nuclei, very complex and it's playing that role. But dopamine allows you to initiate that movement and smooth the movement out. So this sort of makes sense when we look at people with Parkinson's disease, because those dopamine producing neurons in the substantia nigra are dying. We don't know why they're dying, but they die off. And by the time you get around about 80% death, the symptoms start to present. Those cardinal signs of Parkinson's start to present. Again, resting tremor and shuffling gait, for example. And that's because without that dopamine to fine tune, you've got stop-start signals sort of going off, boom, 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 boom. And so they find it hard to start walking, and they also find it hard to change muscle groups. So if they're walking and they need to suddenly stop or they need to pivot, they find those things difficult. If they need to button their shirt, it's going to be a very difficult motor task for them to do. And so, and again, why they get the resting tremor. So then the question is, why can people with Parkinson's disease ride a bike but not do all those other things? And it has to do with the fact that once you hop on a bike, you start to undergo very patterned rhythmic motor activity, which doesn't consistently change muscle groups. You're not changing the weight and direction. So when you're walking, for example, it's actually a very complex motor task, right? So you need to change like shifting weight. The gait changes different muscle groups that are involved. But riding a bike, very patterned and very rhythmic. And it doesn't bypass the basal nuclei, but doesn't rely so heavy on the complex neurocircuitry. And to some degree, it's going into and out of the spinal cord as a bit of a patterned reflex arc that's happening as well. So it's less reliant on the basal nuclei. And that's why people with Parkinson's disease can seem to ride a bike, but not do other what seems to be simple things like buttoning a shirt or walking.
This idea of dopamine smoothing out the motor tasks, it actually helps me when I think about the sort of paradox of the tremor, which is motor activity, and then the rigidity where it's difficult to get them to move. It's just like both of those things are indicative of an inability to smooth out the two oppositional motor groups in those regions.
Exactly.
I haven't heard of dopamine as a smoother before, but it really makes a lot of sense.
Yeah, as we all know, it's anytime we talk about the brain, it's complex, but I think it's a nice way to sort of identify how that dopamine plays that role, right? It does smooth that out, it tweaks it, it fine tunes it. And then obviously with that dopamine reducing, because dopamine, we always hear people, particularly wellness influencers, talk about dopamine's role in behavior and mood and things like that. And yes, it does play that role, and we see that as some side effects of the dopamine therapies that people with Parkinson's disease have, in which it can change mood and behavior and things like that. But really, it's one of its primary roles in the disease is that of the motor activity.
It sounds like it's sort of greasing. I mean, you give a bike analogy, but it's like it's greasing the wheels.
I like that. I should have put that in the book.
Is it too late?
Yeah, unfortunately, but that's great. I like that. That's very good. I will be stealing that from now on.
All right, so I want to ask a question about a different type of motor response, which is frankly annoying. Probably every listener, or at least most listeners, have experienced it, and that's the hiccup. So, like, at the very basic level, Mike, in the book, you talk about hiccups. Why do we hiccup? And if you're able, what can we do to cure the hiccup once we have it? Because please tell me, I would love to know.
Two great questions. And I'm going to begin by asking the three of you a question. So I'm an educator, so I'm going to ask a multiple choice question. So the world record for the longest period of time that somebody had hiccups for, right, I'm giving you four options. You have to tell me which one you think it is. Is it A, 3 years? Is it B, 12 years? Is it C, 37 years, or is it D, 68 years? What do we think?
I'm going to go either C or D because I know it's many, many years on the order of decades. Over 60 seems like a lot, so I'll go 37.
RV, what do you reckon?
I was leaning towards C as well.
Yeah, ditto. Test taking strategy says C.
The answer is D, 68 years. So Tony's right, though,
God.
many, many decades. So this is a guy called Charles Osborne,
That's so
right? And
frightening.
so
Oh my gosh.
he said that in 1922, and this is this is what he said, that his hiccups began in 1922 after weighing a 350-pound hog. And so the
Classic.
doctor said that something. Yes, I'm sure you get many patients coming in presenting with issues after weighing 350-pound hogs, but supposedly something happened centrally, whether that is a bleed or who knows, but it affected his hiccup centers, which we do have in the brain stem, and he hiccuped
Whoa.
from 1922 to 1990, so for 68 years. Long, long period of time. Yeah.
Oh my gosh.
It's horrendous. So I don't know how somebody could survive for that period of time. If I have hiccups for more than 20 minutes, I'm going crazy. So the question of why do we hiccup? So firstly, the quick physiology, right? The hiccup is an onomatopoeia. It is just the sound that we make when we do that action. What will happen is something will trigger the diaphragm to contract. We know the diaphragm is that anatomical barrier between the thoracic cavity and the abdominal cavity. It's dome shaped, so when it contracts and flattens, we get an increased volume of the thoracic cavity. And we all remember Boyle's law: when you increase the volume of a cavity, the pressure inside decreases, and air will always rush from a high pressure to a low pressure. So air rushes into the thoracic cavity, and to protect the airways, we get this closure of the glottis. And that gives us that hiccup sound. That's 35 milliseconds. That's how quick the whole thing is. Closure of that glottis, and that gives us the hic sound. So the question then is, why do we do this? Because when we think about a lot of the things that we do, the effect should be negating the stimulus, right? So if we think about what causes a hiccup, it could be things like expansion of the stomach. It could be so distension. It could be rapid eating, which is probably part of that distension. Carbonated beverages can do it. Spicy foods can do it. So anything that tends to irritate some of those sensory nerves in the esophagus and the stomach can stimulate hiccups. But then that hiccup itself doesn't seem to relieve the stimulus. So why do we do it? And so there's many hypotheses out there. Let's go back to the oldest one. And when I say the oldest one, I mean 370 million years old. We talk about our fish-like ancestors. And so when we think about the nerve that allows for that diaphragm to contract, the phrenic nerve, and where it originates, do you guys remember learning C345 keeps you alive? So the phrenic nerve originates at the neck, but has to travel all the way down to the diaphragm. That's it's not a great design. So the reason why that's the case is an evolutionary reason, because of gills and where our gills used to be located, and the old role of what the phrenic nerve is now in allowing those gills to work. So when we started to transition from gills to lungs, and we started to have both gills and lungs, we needed a way to bring water across the gills without bringing that water into the lungs. And so you can even look at organisms that exist now, like lungfish and tadpoles. Tadpoles are probably a better example here. They've got this transition where they start with gills and then they transition to lungs. And there's a period where they have both gills and lungs. So when they're bringing that water in across their gills, they don't want to bring that water down into their lungs, but they need to bring the water through into their oral cavity. So they will need to, like what we do, suck in, but close the glottis, or close the equivalent of the glottis, so that that water doesn't make it through into the lungs. And that is the tadpole version of a hiccup. And so the thought is, well, maybe that's why we do it, is it's just this vestigial function, this throwback. But for it to last 370 million years is quite strange, until we come a little bit closer to in utero and we see that even fetuses will hiccup in utero. We see this with ultrasound. And so the question is, why would they do it? And it might be the fact that the hiccup is being used to help prepare the muscles of the respiratory tract. They're not breathing yet, but they're just getting it ready so that once they're born. It's practice. Exactly right. So that could be one reason. That's not my preferred mechanism. And again, whether it's my preferred or not,
And it's not
I don't
me
know whether.
preparing to be a frog.
Yeah, that's all right. That's all right.
It's a lot of real estate in the brainstem to devote.
Yes.
I mean, the brainstem's pretty small. If you're going to have a hiccup center, it must be important.
Well, so if we think about it, right, what needs to be stimulated is it can be the vagus nerve.
Should we have him restart? Can y'all hear him okay?
Am I dropped off?
It says actual recording is higher quality. I think some of this is.
Hey.
It's all right. Did I drop away? Did I?
You just, yeah.
Very
Maybe go
briefly.
back to
Maybe just the beginning of the
after
answer.
I called you a frog.
Oh, no problem. So if we have a think about what stimulates that whole reflex arc, we have something that's going to irritate either the vagus nerve, the phrenic nerve, the sensory component of the phrenic nerve, or some afferents of the sympathetic nerves. So something needs to irritate them in the esophagus or the stomach. And so that sends a signal into the brainstem. We don't know much about the hiccup center. We think it's the medulla, and then that's going to send efferents out, and the phrenic is the major efferent to the diaphragm to suck that air in. So if we now have a think about why, as adults, do we hiccup then? If we have a look at our lifetime, the period in which we hiccup the most is as a newborn. So newborns tend to hiccup around about up to 2.5% of their day is spent hiccuping, which is 36 minutes, which is a long period of time to hiccup. And so what we think, and this is why I think it's my preferred hypothesis here, or mechanism for why we hiccup, is that when a newborn is suckling, they're bringing in all that milk, but they're also gulping huge amounts of air into their stomach. And that leads to a distension and irritation of the stomach, vagal afferents going up to the brain, which will then stimulate the efferents for a hiccup. Now, if we think about that hiccup again, we get the thoracic cavity expands, so the pressure inside decreases, right? The air rushes in, but the glottis closes. But when you get the thoracic cavity expanding and the pressure decreasing in it, you get the opposite happening in the abdominal cavity. Because the diaphragm's pushing down, the volume of the abdominal cavity decreases, the pressure inside increases, effectively squeezing the stomach to help get that air out. And you get a burp. And so you hiccup and then burp. And that's why I think it's my preferred hypothesis, is that we see it happening most in these newborns. They do it a lot after they're suckling. They do the hiccup and then they burp, and they're making more of that room in that stomach.
So does that mean that when I'm hiccuping, I should just have someone pat my back like my mom did when I needed to burp?
I would be happy to do that for you, Tony. And I'll say everything's okay. Now, you asked the question, so we get hiccups. How do we get rid of them? So what are some of the ways that you've heard that people get rid of hiccups?
Sudden fright.
Yeah,
okay, we've got that one.
I always learned as a kid to take a spoonful of sugar.
Okay. Have you done that? Have you tried that?
Well, yeah, well, mostly as a child. I think we were like, maybe I'll get the hiccups so that I get some sugar.
Yeah, the sugar that's the win. What about you, Tony? Have you heard any?
Give me some hiccups. The one that I recall is standing on your head and drinking water upside down.
Yes. Which I haven't personally tried. Have you tried it, Tony?
No. Maybe in my youth. I'm not sure that I could stand on my head and safely try to ingest water.
Yeah, I probably wouldn't recommend it. So I think we've got all these sort of theories on how we can remedy the situation, but effectively we need to think about that reflex arc that's sort of happening. And so the stimulation, so we need to get rid of the irritation. So some people get it from spicy food, some people get it from drinking too much carbonated beverages, but effectively something stimulating one of those nerves. And the vagus nerve is an important one here. Some people might have a lesion in the brainstem that could cause the hiccups from happening, that's probably not something that you could take one of these cures for.
Or weighing a
And
350
so,
pound pig.
yes, or picking up, that's right. That's right. Don't weigh the pig. But effectively, what seems to be, so the strangest, or most interesting, I should say, that I found in the literature was rectal massage. Rectal massage. And that tended to be,
Are you hiccuping, Hannah?
No, I'm like trying to control my breathing so I don't. Anyway, please keep going.
so this person had intractable hiccups and they went in and the medico thought vagal stimulation, let's do this as best as I can think, and they did it via rectal massage and it cured. I think they may have won the Ig Nobel Prize for this, for the rectal. So vagal stimulation seems to be an effective cure for it. I don't know whether rectal massage is the best approach. Each to their own, I suppose.
I mean, carotid massage maybe could be like, I don't
Yeah.
know.
If you're hiccuping, it's hard to like blow into a straw because you're gonna hiccup midway through.
Yeah, it's true.
Yes, and you can't hiccup on fully inflated lungs. So if your lungs are fully inflated, you won't get that hiccup reflex because it's inhibited. So one of the things that people tend to do is inhale as much as they possibly can and hold that inhaled breath.
Right.
Also, there's Valsalva maneuvers, for example, can stimulate vagal responses, and so some people tend to try those. I'm not recommending any of these, by the way. So whether some of these supposed cures are seeded in some degree of vagal stimulation, I'm not sure. But the rectal massage, that was a win.
Who knew? Who knew?
Was that listed under R for rectal massage?
That's the A to Z After Hours book that we'll be releasing
Yeah,
next year.
That's book 2. Well, so it's it's interesting. The three, I don't know if we did this on purpose, but the three things that we've lined up here all seem to have sort of a motor component. And the third one that we're gonna cover, that Dr. Mike and Dr. Matt cover in their book, is actually perhaps the sort of final motor activity that someone's muscles do in their life, and that is rigor mortis.
Yes, yes.
So when somebody passes away, their bodies soon go rigid and develop the state of rigor mortis. So, Mike, why does a dead body lock up?
Matt wrote this particular chapter in the book, and he mentioned other types of mortis. So mortis meaning referring to death, right? Rigor mortis meaning stiffening upon death. But there's other ones like livor mortis, LIVOR. This is a discoloration after death. Algor mortis, which is a coldness after death, and a pallor mortis, a paleness, and so forth. Many things happen to the body after death, and one of those things is that stiffening, that rigor mortis. And so this can happen 1 to 2 hours after death in the smaller muscle groups, but tends to really kick in at around about 6 to 12 hours post-mortem, and can last up to, depending on the conditions, right? It can last up to 48 hours, sometimes even a little bit longer. But what's happening to cause this rigor mortis all is seated in the sliding filament theory of muscle contraction, which we all went through when we were studying. And so if we think about a muscle and the muscle's ability to contract, we think about the contractile proteins. Remember those two contractile proteins, actin and myosin? We've got those myosin heads that look like little golf clubs, and they need to bind to the actin. And they need to perform what's called a power stroke to move the actin. It slides it across, and that's the shortening of the muscle. Now, for all of this to occur, we need two really important things. One is calcium, and the other is ATP. And so for muscle, the calcium is hidden inside of the sarcoplasmic reticulum, which is modified endoplasmic reticulum. They're just pools of calcium waiting to be released. And then the ATP that our body produces through metabolic processes. Now, calcium, when it gets released from the sarcoplasmic reticulum, what happens is that the myosin heads can't bind to actin because there's like a bike chain wrapped around the actin. Those binding pockets are not available for the myosin. And so what calcium does is it unlocks that bike chain and lets it fall away so that it can bind to it. So calcium unlocks it and the myosin heads can bind to the binding pockets of actin. But the thing is, we need to perform the power stroke and we need energy. So this is where the ATP comes along. So ATP will bind to the myosin head and tell that myosin head to pop off the actin. And then the ATP will turn into ADP and phosphate. So a phosphate pops off the ATP. And that gives it the energy to cock into position and rebind. And then the ADP and phosphate will jump off and it performs the power stroke. But the important point here is that the myosin head is stuck to the actin. You need ATP to come along to pop the myosin head back off the actin. So when we think about what happens when somebody passes away, the sarcoplasmic reticulum that's storing all that calcium, that's an active process to store the calcium. And so when somebody's dying, that active process can no longer happen and the calcium leaks out and can no longer jump back into the sarcoplasmic reticulum. So calcium accumulates around the muscle. And so it unlocks the bike chains of all these muscles and allows for the myosin head to bind to the actin. And then whatever ATP is around and remaining allows for a couple of cycles of the sliding filament theory to occur and you get contraction. But the problem is we're not making any new ATP after a person's passed away. So without new ATP, we don't get the ATP coming along to pop the myosin head off. We need new ATP to detach the myosin from the actin. So we get the contraction happening, but not the relaxation happening. And so what we rely on for it all to relax is autolysis and putrefaction and things just breaking, enzymes breaking down. And that's why we get that rigor mortis occurring.
See, oh, go ahead, Tony.
Well, so what I'm wondering though is that I typically think about some of the sort of contractile muscle is not the right, but so I typically think about the bicep being larger than the tricep. So if this is happening universally, is there a sense for why if all of this is happening at the level of the sort of the small myocytes, why aren't I contracted at the time of death in sort of my larger muscle groups? Because I think at the time of death, when rigor mortis sets in, someone remains in the state that they were in. But you'd imagine they might actually become contracted where the larger muscle groups are, or maybe that does happen. I just haven't seen enough patients who are in rigor mortis.
It tends to begin with those smaller muscle groups, simply be like the eyelids, for example, and even approaching the jaw. And it seems to be simply because they have fewer muscle fibers required for them to perform their contractile process. And so those larger muscle groups are really waiting for all that calcium to flood the muscle for that contraction to happen, which tends to happen a little bit after that period of time. So it tends to progress smaller muscle groups to larger.
I was going to say, this book, I feel like, for us as physicians, like it's teaching like us sort of, I think, really helpful analogies and concepts that apply to our own bodies and to our patients. But I think especially for people who are say not in healthcare, didn't go to medical school or something, like this is the kind of stuff to really understand how their bodies work and also impress people at parties, I would think. And
That's
so,
the aim.
The
We want
hiccup thing. That's going into the rotation for sure.
So that anyone who can pick it up can learn something. If you're just an interested, teenager all the way up to any particular age, really, there's something in the book for you. We do go through some complex physiology, but our hope is that we break it down in a way that it just makes sense. And there's some really, really difficult concepts to get across, which we hope we've done really nicely. And like you said, Hannah, use them at a party. We talk about everything from the heart contraction and pacemakers to fetal blood supply and how we've got all these detours that occur in utero so that we don't overwork certain organs that aren't ready yet. And so, look, I'm proud of the book. I think that there's something for everybody.
Fantastic. I feel like I just relived a little bit of my first year of medical school, but like in a fun way.
Exactly.
I'm glad you had that modifier at the end.
This is the way to explain stuff to people.
Yeah.
Yeah, it's true.
And I think so, last time that you were on the show, you talked a little bit about your educational philosophy, and I think anyone should go back and listen to that. But this time we kind of wanted to ask a little bit about how you guys built your podcast and your channel and now a book, and what you kind of think the secret sauce is on communicating, on making things accessible, stuff like that.
Yeah, look, in all honesty, and Matt and I say this all the time, and people laugh because they think that we're being modest. We're not overly bright guys. We didn't do well at school. I didn't do particularly well at high school. I didn't even do particularly well at university. I really probably got into my rhythm during my honors and into my PhD. And I realized during my PhD when I started teaching that I really love communicating how the human body works to people. And so that to me was really the impetus to go, oh, I actually get this really sense of satisfaction and joy that I haven't got anywhere else by helping other people learn. And in all honesty, the way Matt and I explain it is the way that we explain it to others is the way that we needed to understand it ourselves. And I honestly thought, look, I'm not the brightest person, so I need to really dumb it down. But the way we explain things seemed to work for everybody. And so I just think that there is a disconnect often in academia, in tertiary education, where you've got an expert in the field who's presenting to first and second years, but they're not bridging the gap from their level of knowledge to the student's level of knowledge. And there's this, and you just can't naturally bridge that gap without somebody doing it for you. And it's the educator's job to build the bridge. So I will begin everything from even if I'm lecturing to the third year students about some complex physiology, I'll go back to the earliest, simplest base level stuff. I'll build quickly, but I'll go straight back there because I don't take anything for granted. I don't take people's knowledge for granted. And I think that's been the most successful thing about what we do. Because like I said, it's just I've set a whiteboard drawing. So there's nothing necessarily overly unique or special. So it must be something about the approach. And I think that that's part of it. Another thing is I'm privileged enough to enjoy it and just do the things that if I love it, I'll do it. If I don't love it, I won't do it. And I do concede that there's a degree of privilege associated with that. But the fact that I can do that helps. If I don't want to do it, I just don't do it. I've become very good at saying no to things and saying that I don't want to do and saying yes to the things that I do want to do. And that comes with age and time and experience and so forth. That's been sort of part of it. And we just want to keep creating stuff for people. We just want to keep helping people. And I get to connect with the three of you. Read Avi's and Tony's tutorials for years and years and years. And, I know that in this conversation right now, there's three people other than me that are far brighter than I am. And I I love that. I like to connect with people who are more knowledgeable and more experienced. And I just like learning. I'm the first person to walk into a room and go, I'm sorry, I don't know. Can you help me? I leave everything at the door. I'm okay to be, not the brightest person in the room, but I will constantly learn and become better and better and better. So there's no ego there. I want people to correct me. I want people to help me. So I think that's part of it too. You have to be like that. Otherwise you don't grow.
The growth part I think is so important. So I'm kind of curious how the process of writing a book has helped you as an educator, because it's such a different format in some ways to what you likely do on the podcast, on the YouTube channel. It's a little bit more long form. And what did you learn about yourself as an educator as you went through this process? And
Mm.
what maybe can others learn about sort of going through a similar process, even if they don't write a full book?
I learned that my vocabulary is limited. That writing is its own art form. I mean, if you have to write in order to know how to write. I know that sounds silly, but you got to just and we became better writers by the end of the book. I mean, we have a look at the chapters that we first wrote, and as we moved through, we had to go back to those original chapters and tweak them because we moved into default mode, which was very academic. We've written textbook chapters before. We do research, so we write papers and articles. This is very different. We needed to engage a different audience, and we can do that on a YouTube video and a podcast where we're talking and we're being comfortable, but you still can't use that exact same language. It's that economy of words that you need to be careful of. And it's very easy for me to stand up and talk about something for an hour, but to talk about that same thing in 5 minutes is way harder than talking about it for an hour, because you need to figure out what's the most important thing here. How do I get it across? How do I verbalize it? How do I ensure that it makes sense to somebody? And so it was trying to be succinct and use the right terms and make it engaging at the same time, and not let my brain, I've got a very typical ADHD brain in which it's jumping ahead of my ability to type. So I moved into dictation. So I would go for walks and I would just talk into my phone and it would dictate that, and then I'll put onto my computer and just do the edits. So that helped a lot, just saying things out loud.
Amazing. Mike, thank you so much for coming on the show. Thank you for just sort of, sharing your enthusiasm, your wisdom, and your just very three-dimensional approach to education with video, with voice and podcast, and now in written form. We're so excited for your book, The Body A to Z, to launch into the world on the day that this podcast is going to launch as well, or post on October 29th, 2020. So people should go buy it wherever books are sold. I think that's the phrase, right?
That's right. That's exactly right. And if you can't find it, type it in. You'll be able to find it, I'm sure.
Yeah. And so, we're just my pre-ordered copy is on the way. I cannot wait to
All
read.
three of you, I'll be sending it direct. It'll be personally couriered to your doorstep. I'll ensure of that.
Well, congratulations again, my friend. Really, it's just it's an amazing accomplishment and a gift to the world.
Thank you. And can I just thank all three of you? Like I said, I love the podcast. I think so highly of all three of you. I read Tony's Substack all the time. Always follow your tweetorials. I listen to the pod. Like, it's just, I love it. And you have all been very kind and generous with your time and your knowledge. And so I think on behalf of your listeners, because I'm one of them, thank you. It's awesome. Keep going. Keep doing it.
Oh, that's very generous, and the feeling is very much mutual.
Absolutely.
Well, that wraps up another episode of the Curious Clinicians. Thank you, as always, for joining us. Claire Morgan of Nodderly.com is our podcast audio editor, and Millennium Mana and Giancarlo Bonoma are producers for the show. You can join our mailing list at CuriousClinicians.com to stay up to date on episode releases and have detailed notes delivered directly to your inbox. You can subscribe to our Substack at thecuriousclinicians.substack.com. Physicians and other healthcare professionals can earn CME and MOC credits from VCU Health just for enjoying this episode. For more information, visit ce.vcuhealth.org/curiousclinicians. And as always, the information contained in this episode is for educational and entertainment purposes only and does not constitute medical advice. Until next time, we've been the Curious Clinicians.
That was fun.